صباح الخير دكتور.
صباح النور. أهلا وسهلا. السلام عليكم.
عليكم السلام ورحمة الله.
And I don't know whether Dr. Qaisar finished with you or said he will take you more. He will take you another week or another 2 weeks.
No, I think you only have one lecture left, but I'm not sure.
Well, probably. Really, today we can finish, but well, next week is optional, and you may ask me to give you certain things or repeat something, but.
Doctor, but the next week is the exam, yes?
Well, really, I don't know whether I will examine you alone or with the other student. I will see. I will contact Dr. Suzanne. I will see whether your examination will be alone or with the other student, yani, or the like other material. Of course, you will. Really, in the exam, you need your laptop. Certainly, you need your laptop and also, I think, connector or sayar, probably because you need electricity, I think. So.
يعني مثلا مع الامتحانات مع آخر السنة، يعني مثلا راح يكون مع الميثودولوجي، يعني شلون نلحق؟ يعني ما ترهم، يعني لازم يكون واحد قبل الامتحانات، مو صحيح؟ يعني يكون أفضل لنا.
Yes, probably.
يعني لأن هو محسوب علينا مادة واحدة، يعني لأن هو محسوب علينا مادة واحدة، وإحنا أصلاً يعني مدة الامتحان من 7 إلى 17، يعني يدوب 10 أيام.
So you say we'll do the examination next week alone. So, well, in this case, you have to bring your laptop really, and also and you should, every one of you should bring sayar, يعني connector, يعني you can probably you need to شاحنة تربطون شاحنة. So
يعني internet دكتور، net يعني.
No, probably net is not necessary because well, if there is internet, we can, of course, we can send you the by Wi-Fi. Yes, I can send you the questions. Or probably I will try to print the questions, print them, or I don't know. Probably there is internet. Probably if there is internet, it's easier, of course.
يعني دكتور هي نفس طريقة هذا مال الميد ترم، يعني هم نفس الشيء داتا وبس نسوي عليها التست، إلا غير شكل راح تكون.
No, it is the same. Just it is just I will give you a data, but it's a smaller data. Really, a smaller data.
Yes.
Okay. So I will give you a smaller data, really, and we'll see if it's by Wi-Fi. It's already entered. If not by Wi-Fi, well, I will put it on paper. I'm not sure. Yes.
دكتور
بله
ما يصير دسنا نص ساعة أو ساعة قبل ما نجي للكلية احنا نسويها داونلود يعني يمنا ونجي.
اوكي.
يعني احنا بال11 ونص امتحان، مو بال11 دزنا او 10 ونص احنا ننزلها يكون حاضر يمنا حتى نجي كله عنده باللابتوب، يعني حتى ما ياخذ وقت او مشكلة يصير، واحنا ما نعرف شنو نسوي بها اصلا يعني. حتى تنطينا بعدين الأسئلة عليها.
Okay, well, possible.
أحسن دكتور همين.
Okay. Well, okay, I will send it to you. Yes, I will. Okay, this is good suggestion, so that there will be no problem. Yes, okay.
يعني مورنينج مال الامتحان إذا دزنا مورنينج بالمورنينج.
Yes.
احنا ننزلها باللابتوبات مالتنا بالبيت، كلنا عندنا انترنت بالبيت.
Yes.
ويصير بدون مشكلة هنا.
Okay, very good. Okay, معقولة. اشتكي معقولة. So I will send you the data, and then as the college will we can also ask you what to do with it. Yes, ask you what to do with it. Okay.
Yes.
Now next week, of course, I think the college will be empty, and we can't take any hall because the examination, the midterm examination, the mid-year examination will finish this week. I think the undergraduate will finish the exam. So last week, the place would not be a problem, I think. The place, but I think for laptop, probably you need a connector. يعني في السيارة, especially if you're not شاحنة. And if your computer like me, I need شاحنة, so you need probably to bring a سيارة with إضافة إلى الشاحنة. Okay. Okay. So well, it's very good. I will of course I will send you a small data set for the exam, and then we'll come to exam. So please, you should tell me, of course, what is the day of the exam, and what is the day suitable for you. Of course, you will, all of you, the PhD, and are pharmacy and College of Medicine. I think you should agree on the day, because I will examine you together. Okay. I think we need to.
خلي اتفق ويا الدكتور برهان بعدين دكتور ويا جماعتنا كلنا يعني.
Yes.
يعني هو 25 بالشهر احنا اتفقنا مو بس يعني اذا بها مجال يعني احنا هم واحنا الاسبوع اللي وراها ممكن لان عندنا هوايه التزامات هم بهاي الاسبوع اللي.
Yes. 25 يوم Monday يعني.
بعد
من Monday.
لا دكتور 24.
لا احد نفس اليوم مال هاي قصدي.
اوكي.
يعني بالتاريخ غلط. 24. ممكن 24 او 31
راح يكون قبل الامتحان دكتور ريدير يعني اول ماده.
ايه اسبوع قبل الامتحان.
لا دكتور خليه 24 ما مشكله.
24
اوكي 24 يعني هاي الاسبوع اللي يجي دكتور وهاي اخر محاضره مو اليوم.
بله
ايه فالاسبوع الجاي احنا اتفقنا قبل يعني احنا وجماعه هاي يعني اتفقت يعني طبيه وفارماسي كلهم يعني طلاب متفقين على ال 24.
So it will be 11 o'clock 11 30
11:30 لان عندنا حلي لي 11 محاضره مال الميثودولوجي نخلص حتى.
Yes, 11:30 yes. It's also I have a lecture with the MSc, so 11:30 is okay.
دكتور شو راح ندز لك تجاوب الامتحان؟
Well, I think I should really the question could be solved by on the computer in order to make a document really, to make it an official document. Really, I think that it's possible for you to answer on the. I'll bring a copybook from examining copybook from Dr. Amr, and then probably you can put the output to not be an extensive output. You can put the output on the copybook. I don't know, probably, or we. Really, I don't know. Then it's the first time to do such exam.
دكتور يعني مثلا جداول وهاي التيبلات الجراف يعني شلون على الكوبي بوك؟ يعني تيبل جراف. زين دكتور فكره احسن ليش ما تدز لنا هي مثل المتر ونسويها في البيت وندز لك هي وخلاص.
Well, it was simple. It was a training for you. That was a training for you. Now the exam really should be real, yeah, not virtual. يعني exam really should be in the college really. Okay. So we'll do it in the college. But really, I'm wondering whether I should do it on a copybook or just that you make me a Word file and then I take the Word file from you. Really, I'm not sure. Really, I'm not sure of that. يعني in this in every case.
اقتراح آخر.
بله.
اقتراح آخر إذا يعني بال11:30 هو امتحان مو؟
بله.
بال11:30 إذا تنطينا هم زوم لينك نفتح الأونلاين يعني زوم وكلنا نفتح هاي مالتنا حتى نعرف يعني كل واحد مكانه يعني.
بله.
نفتح أونلاين ونشتغل يعني بتسألنا أونلاين وإحنا نشتغل وراها يعني فترة قصيرة يعني لازم ندز لك الأجوبة هيك أو ما يصير هيك. يعني إحنا حتى كلنا نفتح الكاميرا حتى نقدر.
You want to do the examination
إذا عندنا
يعني virtually يعني ما
يعني أونلاين بس عن طريق بس أونلاين هو يعني نفتح الكاميرا كلنا وأنت هم يعني تشوف وتسألنا إحنا نجاوب تنطينا ساعة ونص يعني بكيفك حتى اسئله واحنا نجاوب وندزك بالايميل وخلاص، يعني ما يصير اي مشكله بيه. يعني الكل عنده انترنت بالبيت. او لازم نحاول هاي واي فاي نوت بوسيبل. هاي
ثواني.
وعليكم السلام ورحمه الله. دكتور سعيد. الحين دكتور سعيد.
دكتور
بله.
Doctor, what about the CD, the idea of Doctor?
Yes, CD. We can put it on CD, each of us.
Yes.
Print it and give you the document in college.
Well, all of you have CD.
You send the data as Doctor released at morning.
Yes, I'll send it data. I'll send the data for you, and then probably yes. What problem is that some computer they don't contain CD. Well, of course, if your computer doesn't contain CD, yes, you can make a CD. Yes, okay, CD is acceptable. Okay, so it will be a document for the exam. So CD will be document. If your computer, like my computer, doesn't have CD, so you can simply have a flash memory, a clean flash memory, a new flash memory, and then give me the answer with the flash memory. Okay, it will be a document. A CD is better, but if your computer, probably some of you have laptop which doesn't contain a DVD writer or CD writer, so you can bring a flash memory, small flash memory.
Yes.
Can you do that? You should.
Yes, it is easy, Doctor. You have two options, either the CD or the flash memory.
Yes, and that will be.
I think the flash memory will be easy for each of us.
But the flash memory, a new flash memory, okay, and it should be empty. There is no need to be a very big flash memory, and a small flash memory, a small size يعني.
إيه دكتور راح نكتب أسامينا على الفلاش ميموري حتى يعني تعرف هذا مال منو؟
لا بالدوكيومنت مال.
هو هذا قصدي. يعني هو هذا قصدي.
In document you will write.
Yes, you can sometimes name the flash memory. Yes, for example, my flash
هو
memory.
هذا قصدي يعني من دخله بالكمبيوter على الاسم. Yes,
you can name. يعني flash memory you can name it. Yes, you can give it your name. Yes, you can put your name, and also you can the file. Also, you can make it put your name. Some of you have sent me the file, the output with his name, or the SD file with his name. Yes, you can. يعني you can write يعني make the CD or the flash memory with your name, and also you can name the file also with your name, especially the Word file. Okay.
ها راح نسوي وورد هم دكتور يعني مو بس output.
Well, of course, our aim is that our aim of the course is that you not only analyze the data, but also you make them suitable for putting in a thesis or in an article. Really, some of you really haven't made that in the midterm exam. Really, they have sent me almost a raw data. يعني. Some of you, of course, some of you have tried to make a suitable Word file, and even some of you, I think, in pharmacy, some make a PDF, nice PDF. But usually we don't want the raw SPS output. The raw SPS file output is not suitable really for publication. As we saw we see this week again now, the output given by the SPSS is not suitable for publication. You have to clean the output. For example, for association, the SPSS really give the association in form of matrix. Some of the R are repeated. They repeat the R 2 times or 3 times. So you have to remove that. As we saw in I think one day we saw that in biochemistry output, that we put 1 R. We don't need to repeat the R like SPSS. Also, sometimes in the frequency distribution, there is something called valid percent. If there is no missing data, there is no need for this column. Again, if there is only two categories, there is no need for the cumulative frequency. Some of you, for example, they send me the frequency table with valid percent or with cumulative, which is not useful. So we want really to put the useful thing. I want you not only to send me or give me the output from SPSS. No, I want a clean tables and a graph, a clean and suitable for publication in a Word file. Okay, this is what I want. Okay, So I think really today
السلام عليكم.
بلى وعليكم السلام ورحمة الله. أنت برهان.
عزيزي دكتور. العفو دكتور بس I think it will take much more time, especially we are all amateur in the SPSS, so it will take so much time to make a clean word for you. Because I remember when we did the last time for the midterm, we were spent much more time on the word instead of doing the data. So doing the data and make it on SPSS was much more easier than doing on the word, because taking the data from 2 different tables for each test and mix them, and sometimes we need to make a pivot. So I think for the final exam it will take much more time. What do you think?
Well, I'll bring you any simple output and simple not that complicated. Also you will not wonder what to do. You will not take time to know what to do, because in the lead example, I didn't say to you what you have to do. I said simply the aim is to find the relationship of real function to lead. But in the example, really in the it will be first it will be a small data set, and I will say you what to do, and I will say you what I want. So you will simply do it in I think it will take short time really. If you just send me the SPS output, well, that will not be useful for you. If I send someone SPS output, if you ask me or you ask me to do a statistical analysis, and then I send you the SPS output, it will be useless really. Really it will not be useful. Probably just you'll just look at it or explore it, and but you can't put that in your thesis. You can't put it in an article. I want something to put in an article. I want a clean output, a simplified table and graphs. But I will make it simple really. I will make it simple for you. Okay. I'll not make it difficult for you. Okay.
دكتور هي نفس المطالب مال الميد ترم لو بعد راح ينضاف عليها؟
لا العفو in the midterm there was ما كان لكم مطالب. Simply was the aim.
لا قصدي descriptive والcorrelation وهاش الديفرنس.
And also I will give it to you specifically. I will set to you what to do.
قصدي المحاضرات اللي بعدها أخذناها regression وهاي هم مطلوبة؟
Well, you should know it, of course. You should, because the purpose of giving the course is giving you advanced statistics, which include regression and survival and non-parametric tests. You should have idea about this really. And you should have idea about this, I think, because we have already give that.
Okay,
we have gave that and given that, and I think, but it will be simple really. If I give you a regression, I will ask you to do it in a simple way, not that difficult. The data set will be small data set, and the requirement will be small. And really for your for your midterm exam, really, some of you really give me good output, and probably one of you really took 90, good output. Few of you took 85. And really, the rest of you, most of you, many of you took 80. Really, I didn't give less than 80. So, I don't know, probably the mark will be 25 or 12.5, but from 100, really, I didn't give less than 80. Really, some of you deserve less than 80, but really, I didn't give less than 80. 80 from 100. I said, really, many of you take 80. Few of you take 85. Really, one of you take 90 because the output was nice, really, and very, very suitable for publication. So really, that of course will help you. The mark is your mark is high already. But I said some of you made mistakes, and some of you really make big mistake. Like for example, making per t-test. Really, we don't have per data. In the lead example, in the lead and real function, the cases, the 418 cases, were not paired. It's not paired. We don't have any pairing. So we should really, we do, as we see, either Mann-Whitney or the Wilcoxon rank test for 2 sample, or the unpaired t-test. So يعني I think some of you did one of you make non-parametric. Most of you make the unpaired t-test, but I think two of you make paired t-test, which is really a mistake يعني because we don't have paired data. Paired data mean that يعني you for example test the same drug on the same individual. You test two drugs or two vaccine or placebo and vaccine on the same individual, which we don't have it really. We didn't have this. Also another mistake really, I think some of you make one sample. It is not present. I'm not seeing someone make a one sample test, which is again I wanted two sample tests, not one sample. We don't have a real in the lead example. We don't have a population and mean. We don't have population and sample mean. We don't have really. We don't know the population mean of lead or renal function. So really one sample t-test again is wrong really, another mistake. And as I said, some of you didn't give me a clean output. Still really, I didn't give less than 80. So all of you take at least 80 of 100, okay? I said a few of you took 85 and one of you take 90, okay? So really, it is a good mark for you and it will help you, of course. And as the exam really will be simple. I think the exam will be even more simple than the lead example, okay? The midterm. Okay. So then primarily we agree that next week and in the college I will send you before you come, I will send you the data set. Then in the college at 11:30 we'll meet and you will do I will tell you what you have to do and then you make them and give me a CD or a flash summary, okay? Of course, you name the output with your name or the flash summary or the CD. You make it, you give it your name, okay? And that will be a document for the. If ask me, if they ask me for a document, I will provide them with the CD or the flash summary. Okay? Is that okay for you? Is it clear? Yani, there's no problem. Is still there are problems, Dr. Burhan?
Yes.
Problem? What's the problem?
No, لا دكتور سعد كلش واضح. بس عندي شغلة ثانية دكتور سعد.
It will be simple, really. It will be simple, and I'll be with you. I will be with you, so it will be simple. يعني.
Dr. Saad, do you have time to explain for us how to change, يعني even يعني a short time, to give us some pointers about how to change the output to a good Word document?
Really, I think you have, if you go to the Zoom, if you go to the Moodle, to your course, there is I think in the second PowerPoint, in the second presentation, the second lecture, I explained that really. I showed that to you. And today I will show it on non-parametric tests. I will show that on the non-parametric tests. I showed really. I think if you return to and see the second lecture, have you seen your course on the Moodle, Dr. Saeed?
No.
No, Dr. Saeed, you have to go to the Moodle and enroll you.
I don't have any idea about that.
Moodle. No.
اي دكتور موجودات كل الزومات موجودات هناك.
Yes, Dr. Saeed, also you have to go to the Moodle. The Moodle is Dr. Burhan have make a course really in the site of the College of Pharmacy. So you do College of Pharmacy postgraduate, and then you find this advanced medical statistics. I think that Dr. Burhan has named the course advanced, not advanced medical statistics, and you enroll yourself as a student. You can enroll yourself by your UOD account, and then you enter and see all the videos or all the. Okay, Dr. Saeed.
Okay, Doctor. I will arrange with Dr. Burhan.
Yes, يعني
دكتور
into the course. بلي دكتور برهان.
العفو دكتور. بس توضيح كل الجماعة اللي موجودين معنا هسه كلهم موجودين بالمودل كورس. يعني already when they going to their dashboard on their Moodle, they will find that there is a course named Advanced Biostatistics PhD.
Yes.
So they don't need to enroll themselves. I already enrolled them.
It appears, yes.
Yes.
Yes,
Dr.
this
Said
is
also, can you see that on your model? Dr. Said?
all of them.
You have to go to your page in the model, I think, Dr. Said.
Yes,
And
your
you find the
dashboard.
course.
I will talk to Dr. Said later. No problem, Dr.
Okay.
دكتور العفو، بس بالنسبة للموضوع مال ميد ترم،
Yes.
إذا ممكن وإذا حضرتك عندك مجال يعني
بل.
اليوم لو مثلا بعدين كل واحد بصورة شخصية يعني دزنا مثلا كومنتات مالتك على الداتا اناليسيز مالتنا، على الاوتبوت، على الوردز، شنو الاخطاء حتى ما نسويها
now I talk in general, but of course some of you have understood that some of you know already what they have done, the mistake they have done already. I took in general, but probably yes, I can send by email the note on everyone output. Yes, I can send that really.
Okay.
Really, I said general notes, but I can later on set that in general. Okay, for everyone. Yes.
دكتور ممكن يعني تسوي لنا أجوبة نموذجية للداتا اللي دزيت لنا هي حتى ما نخطأ بها مرتين.
Yes, well, really, I've tried. Really, I've tried to do. Yes, I have done something. Really, I have done something. Really, probably. Let us search screen. I'll show what I have done. Really. Well, of course, I have done. Still, really, I thought I will work more on the data, but probably this is my output. Really, I haven't. Well, this is my. I think this is my output. Yes, it's a Word file. Let's see it. Yani. Well, still probably I made regression, etc. But really, there was something with the problem with the sex. Really. So really, this is what I have done. Some of you already done that. Really, they make a description for the. So you are you seeing the Word file?
Yes.
You see. So this is what I have done. So I make this table, and some of you really have made this table, and they made this. They describe the data, and really I describe them as numerical data. Then I describe them as categorical data. Really, some of them already male, female, already categorized. Now, PB, of course, this division is, I think, given by expert, by Professor Dia. And then, well, subcreatine really probably I make it 1, but probably 1.4 is more accurate because it separates the normal from the abnormal. Really, it would have been 1.4 is better, really, but I make it 1 probably because I want this group to be more. Well, criminal filtration rate, I know that the normal should be more than 90, really. I know this level from the really. I read about the subject, so I knew that the adult glomerular filtration rate should be more than 90. Okay, but really few are left in the abnormal group. While here, probably again, if I use a cutoff point of 1.4, probably again this will be less. Probably the number 19 will decrease again. And then by body mass index, of course, only there are 2 groups here. There are the normal and the overweight. Of course, there are no really there are no obese really. There are no obese, and if you come to here, you see there are no thin and no obese. Well, the maximum. So only 2 categories are possible, and some of you really have noticed that it's only 2 categories are possible for the body mass index.
أنا سويتها على شكل chart.
Yes, okay. And okay, I saw your result. It was reasonable. Then I make this for the correlation between PB and ALD for just in order to show that really they are related inversely. They are inversely related, and the real correlation is very high, and also the R square is very high. Also, what's called coefficient of determination. Probably, of course, I expect the result will be the same. And if we make analysis for PB or for lead or for ALD as a dependent variable, the result will be the same. Then really I I continue to show the relation between, of course, some of you already done that, really many of you have done this, show make a correlation and also show the histogram, show the correlation graph or the scatter diagram. Many of you have done that. Then really I try to show the relationship between lead, which is the main question of the study, lead and renal function. And already some of you have done that really. So this is the lead categories and the mean standard deviation, mean difference, and confidence interval and the p-value. So both of them really show to be, there's a relation between lead level and renal function. And then probably, again, probably I show this for categorical variable. Probably one of them is sufficient, but I return again to categorize serum creatinine and measure its association with the or test association with lead categories. So it's really the same information given here. So yeah, it's clear that there is a relation between renal function and lead level. And again, I done this for glomerular filtration rate. Again, I divide this into two categories, and it was really significant, but on the borderline. Really, I also made a regression on lead, logistic regression for lead on, and I use really I mean no. I use serum creatinine as dependent variable. I think I made a linear regression. Serum creatinine as continuous numerical variable, independent for linear regression, and then the independent variable were lead. Really, lead was really a powerful predictor, and also I think also the other predictor was. I think even body mass index was a predictor. However, when enter the sex really into the equation, really we lost the significance. But it seemed really the lead is very correlated to sex. So really, males tend to have a higher level of lead. Male as their occupation, they tend to have a higher level of lead. Therefore, really, when we enter the lead and the sex into the equation, into the multivariable equation, linear regression, we lose the significant association. Really, therefore, I wanted to clarify this more and to put it later on, but I stopped here. So, we can do a linear regression really. We use the serum creatinine as a dependent variable, and we use the lead really. We have lead as a independent variable. Lead, the main lead. We have really the other variable are sex and body mass index. When we enter body mass index, well, still the equation is okay, but when we enter sex, really, we lose the significance, which means that really, as I said, the male tend to have higher lead level, and therefore they usually obscure the relation between lead and renal function. Okay, so this is really as you see that my table are simple, and my table are simple, understandable, and clarity is very important. To be clear, if I put the SPS output not that understandable, the SPS output is really, let us return. I will show you the SPS. I will close this, and I will show the SPS output. Really, it needs cleaning. The SPS output.
Doctor, on your table there is lines. Is that fine? You said remove lines.
Yes, as you can really depend on the instruction. Sometimes really the instruction of the journal or دراسة عليا is to remove the lines. Yes, well you are right. Sometimes you have to really depend on the instruction. Really, if they say to you, So these are really the output. Even these are I've cleaned them really. And I have, for example, I remove the percent here. There's an equation here. I remove it really. So even this output has been cleaned. This output is cleaned really. And for example, there was here two correlation. I remove one of them. Even this output is cleaner than the original SPS output. Okay, really. Really, for example, this is the independent, the t-test, the ampere t-test. You see, there are two. So you have to depend on the second because the Levin's test is for equality of variance is significant. So we have to depend on the second really. What is really both of them significant, but probably I think the constant interval is different. The constant interval is different for the two really. Really, then this is the SPS output as you see, and I think we have, for example, this is the chi-square test. You cannot put all of this in your thesis. What you put the p-value, and you put only the p-value of this. Okay, so I think you need to. I think the SPS output I think is not suitable for the. Well, we return to the. I evaluated the serum creatine as an independent variable for regression. I find it also, and it is not normal. Therefore, I went and go and use logistic regression. I think I used because so I think I divide the GFR into two categories, and then I do logistic regression, and this is really the result. Okay, so this is only lead. It is really significant, and another. When we enter body mass index, still lead really remains significant. So still we don't have a problem. Still lead with the body mass index when really the problem when we enter, I think when we enter sex really, well, still significant. I think when I enter again, this is okay. Well, no problem with the no problem again, as you see, no problem with the serum creatinine or glomerular infiltration rate. I think so. Body mass index. I think. Well, I have not shown the. Really, I haven't shown the again regression. Let's see. I think when I enter the sex, there was a problem. Okay, so okay, so this is one. This is the real problem here. I face the problem when I enter lead and body mass index. There was no problem. Still, the effect of lead is apparent. But when we enter sex, really, well, we lose the significance. So really, it become not significant. Okay, the really the become the the p-value become not significant, as you see, not significant. Okay. Okay, so this is really, as you see, the SPS output is not suitable. Really, I don't see it is suitable. So therefore, I said, if you try to make, some of you already really made PDF, and even some of you made even PDF or Word very suitable, not a problem, I said. So this is really the purpose, is that you learn how to make an output or result with Word file, okay? Okay. Now today really is our subject is non-parametric tests really, and so the example here is really data are student data and score. So really the score for 2 exam as the beginning. There are score for 2 exam, and score really there are for 39 students, not that large sample really. Really, I go and read about the non-parametric test. So really, some of you analyze the data. They analyze the creatine level and the blood level and found it to be not normal. Therefore, they did non-parametric tests. But really, the sample was 418, and really, I want to read for you this. I mean, is that really when the sample is large, even if the distribution is abnormal, is not normal. I'm not seeing the beginning of the really. Well, I think the statement which I want you to see is not present here. Well, not present here. I think I've lost it. Really, I couldn't. So really, if you read your book, the book which I give you in the course, which is present again in model, really it said when the sample is large, you don't worry a lot about normality, because central limit theorem said the central limit theorem, which is the basis of statistical inference, say when the sample is large, sufficiently large, more than 30 in case of numerical data, and more than 60 in case of categorical data, proportion, yes, no, or male, female, more than 60, then the really the means distribution in the population will be normal, and the sampling distribution of the means in the population will be normal. So even if the distribution of the in the sample is not normal, the sampling distribution of means in the population is normal. Therefore, we can really use t-test. Really, we can use t-test even if there is skewness. Therefore, most of you really analyze the data by t-test, which is correct. Really, I think one doctor in the pharmacy, or probably another one, I don't know, they analyze by non-parametric test, which again correct, really correct. I said them that you are correct, but really you can't do parametric tests. Why? Because as we said, when the sample is large, really the central limit theorem said that the sampling distribution tend to be normal, even if the original distribution of the sample is not normal. Really, what makes us worry when normality is not present in the small sample. So especially less than 30, sample is small, and this is frequently present in medical literature or in medical research. Really, in this case, really probably the role of the non-parametric test is important. So really, if you read your book, or if you read this the PDF here given to you, you'll see that when we have a small data set, we start to worry about normality. So either we test the normality. If it is normal, well, we can, of course, we can do the test. If it is not normal, we can also do histogram to see the normality also. If it's not normal, then in this case we have a transformation. So the other solution really is transformation. We can transform the data, and we can make it. We can take the natural logarithm of every data, especially if it is skewed to the right side. It's body mass index or serum cortisol, and skewed to the right side. We can take the natural logarithm of every data. In this case, it will be normal, and we can do a parametric test like t-test or analysis of variance, which are really more powerful than non-parametric. We prefer them. And the other solution, if you still transformation is not suitable, doesn't give you a normal data, or you want to work with the original data, in this case you go and do what's called non-parametric test, non-parametric. Usually non-parametric here depend on ranking. They rank the data. They don't maintain this. They contain, they convert this into rank. So really, this, for example, this student, they are 39. And if you test, for example, the score, and if you test the score, for example, I test the score, I'll go here and I test this by one sample, what's called Smirnov Kolmogorov test, etc. I will remove this. To score. So let's test the to score. We see the normality. So really, I think it will take time. So it will set to us that the score is not normal. And because really it is 39, it is, well, to some extent a small sample size. So if I am worried about normality, I can do non-parametric tests, as we'll see here. We'll do a non-parametric test to compare between the two students. Really, I don't know whether the results still. Well, I'm still waiting for the result. Probably. Let's say wrong. So you see that this is the test really, and for both of them really significant. Yeah, reject null hypothesis of normality. So that really the null hypothesis say they are normal, and we reject null hypothesis. So they are not normal. Distribution is not normal, and you see the graph. They are not normal really. The score of the student is not normal. Certainly skewed to the left side. So some of them have very low mark really. So both of their score really, they are not normal, okay? Obviously the data not normal, okay? So then if you want to, then these are the data. So we want to really test difference between, these are score for they are different students, okay? So students are really here, suppose we are testing students who are different, okay? So these are, okay, so now what we do here is we can do here, if they are different students, we can do what's called a Manuti, or called Wilcoxon rank sum test. Okay, so we go here. We can do it really with this, but it's better, I think, to do it with the classical legacy test, legacy form of the test. Okay, so I will say independent sample. I will enter really the if we do the Mahuti test, we have to enter this into both exam in one column, and the grouping variable really will be the code for both exam, and I think the code for both exam, they are 1 and 2. So we are just doing something similar to the Ampere-T test. The Ampere-T test, okay? So we enter really in one column, both exam, the score in both exam, really they are in one column, okay? And really, so I put really the score in one column really, and I give a code really, a code. So these are the exam of the mark in one column really, and this is the code. Okay, this is the code. So really I haven't named the code, but these are group 1 and this is group 2. So now we are just making something like the Ampere-T test. Okay, so come to here, and this is the independent sample. So I return to enter both exam, and then the grouping variable is this. Okay, so I said 1, and 2. And they say, okay, of course there are probably more than one test, but this is the test we use manually. So really it will give us a rank, yani it will give us a mean rank. So it ranks the data, yani these are and this will not remain the same. So these will be ranked. So yani if the institute is marked is 45, it will give him a rank and tertib. It will the rank mean ranking or tertib al-tulab according to their rank, according to their mark. So someone, for example, this mark is 20, it will take rank 1, and the highest mark is 100, it will take the highest rank. It will come at the end. So this is really the rank, as you see, and this is the mean rank. Really, here we lost the sense of the data because it is not the mean of the data, original data, and give us really a significant. Really, you see the difference is not significant. It is 0.066. So the difference between student and here they are really different students. They are not the same student. Okay, so despite that there is difference in the rank, and despite that if you do a usual t-test in them, you see that there are. Let us see make the usual t-test, the parametric t-test with them. We'll enter this and then the grouping variable. Again, compare between parametric and non-parametric. So usually, really, parametric is more sensitive, yani more likely to detect. So this is the usual test, and really it is again not significant. So really, the marks are really different. The marks are really different by 5 marks, almost 5 marks, and despite this, the difference is not significant. Okay, whether by parametric and non-parametric. It is better, of course, to do the non-parametric. However, the non-parametric really, in this case, the original data become rank, while in the parametric really, we have the mean, the real mean, and standard deviation, and also the standard error, etc. So really, we prefer the parametric. But in this case, because our sample is small, I tend to be small, and really it's not that small, it's 39. But we decide to do non-parametric. But of course, we lose one. We do non-parametric, we lose the mean, real mean. We some still, as I'll show you, some really they put the mean as standard deviation, but use the non-parametric test. Some journal they put these values because these are meaningless really, and they put the p-value from the non-parametric test, as we see, which is not acceptable, but still they made this. You can find it in some journal. Okay. So this is the unpaired t-test and the Mahotti test, or there's another test called Wilcoxon rank sum test. Okay. So they are both of them really give the same significant. Both of them give non-significant result. Now suppose that they are the same student, and we have done 2 tests on them, and they are the same student. In this case here, really, the SPS requires that we put the score of the 2 tests in 2 columns, not in 1 column. While when they are in independent case, in the unpaired case, we put them in 1 column. In the paired case, when they are the same student and we are testing them 2 times, we should put them in 2 columns. Okay. Then really, I want to test what I want to see the normality of the difference. So I make an equation and make the difference between them from compute variable. As we learned, you can use compute variable to make the difference, and then we test the difference for normality. So again, we go here and let's remove this.
So, sorry, Doctor, can I ask question?
Bale.
Doctor, in addition to the small size of the sample, what other indications here require to use the non-parametric test?
Yes, the shape of the histogram.
What about its shape?
What we said, we show the shape really. We show the shape here of the. These are not normal. The score are not normal. Skewed, and highly skewed to the left side. They are not normal. They should be normal. So the shape of the histogram indicates that they are. Even in the lead, your colleague probably also demonstrate. They tested the, I think Kajin or Dr. Manhal. They tested the lead and find it to be not normal. Therefore, they use non-parametric and correlation, and they use Spearman and not instead of Persil correlation. And Dr. Manhal, I think, use also Manutni or Wilcoxon rank for the lead example. So when you see this, these are not normal data. Okay. These are skewed to the left side. They have tail to the left side. So indicate that you need a non-parametric test. Okay. So let us here we'll test the difference here. We'll test the difference again.
They are not normally distributed.
Yes. Therefore, we use non-parametric test. So really, I remove this.
Yani still you can use parametric or you are obliged.
Well, I think non-parametric will be more scientific. Yani the journal usually, if they are strict in their statistical principle, they will say you have to test normality and to do non-parametric test. Really, yes. So,
Afwan, Doctor. But I think all the tests of the normality are so sensitive that make or give most of the time give us the non-normality of the data,
yes.
or say that the data are non-normal distributed.
Yes, really, I have
so
seen
I
that.
think,
yes.
I think it is in my idea. I think it is better to just check the histogram and also check the mean and median. If the mean and median of the cases are close to each other, of the parameter are close to each other, so it means it is normal. So for example, in our case of lead, also I checked the mean and median beside of the histogram and scatter plot too. All was so close to each other.
Yes. Yes, true. And also your sample is large. Really, in the lead, in what you make you confident of the parametric test. That parametric test is suitable is that your sample is large. It's 418. Really, I for Dr. Manhal and for Kajin, really, I didn't say you are wrong. I didn't say they are wrong. They have done something correct. But really, if the difference is really small, probably they can lose a significant difference, because, as we said, non-parametric tests are less sensitive than less sensitive in a production of rejection of null hypothesis. So really, using a parametric test is better. But using non-parametric tests, Dr. Manhal, I think Dr. also Kajin, they tested they make this test, Komarkov-Smirnov, and they find the test is significant. Therefore, they use non-parametric, which is again acceptable. Really, I will not say that to them that you are wrong. But if they do parametric tests, take into consideration the thing which Dr. Burhan said, the small difference between mean and median and the histogram, and also the large sample size, probably it will give them a more powerful result, more high power for their test. So this is really when we do a paired, we are in the paired case, we test the difference. So difference again here is really difference is abnormal. So we are testing, of course, this one. These are supposed they are paired example. We are testing a score. We are supposing these are score for the same student but different exam. So here we test the difference for normality, and we find it is abnormal or not normal, non-normal. Therefore, we'll do a test which is called the Wilcoxon rank sum test. Wilcoxon rank sum test. While the test which is similar to Manutni called Wilcoxon rank sum test. The test here is called Wilcoxon sign rank test. Wilcoxon sign rank test. Okay. So this is the test really is done, which is similar to the PERTI test. So again, we go to legacy and we go to two related example. So here we enter the two score. So this is similar to a PERTI test really. And it's called a Wilcoxon sign rank test. Wilcoxon sign rank test. Okay. And we say, okay, so this is the result. Okay, so this is the result is significant really. So while in case of unpaired t-test, unpaired non-parametric test and unpaired t-test, we obtain a significant non-significant result. Here we obtain a significant result. Okay, even if you do the usual PERTI test, let's see PERTI test, we do a PERTI test. Let's enter again, we do the PERTI test. Even we obtain a significant result. So whether parametric or non-parametric, we obtain a significant result. Why? Why we obtain a significant result in case of PERTI test? So the PERTI test usually is more sensitive, really. Yani, PERTI test usually, when you compare the same individual 2 times, and you give them 2 drugs or placebo and drug, and you compare them, it is better than, and you are more likely to obtain a significant result than comparing different individual. Because the same individual have less variability. So you see variability affect the result, affect the p-value. So when you are comparing the same individual 2 times, and you are making examination for them 2 times, or you are giving them placebo and drug, or you are giving them 2 drugs, standard drug and new drug, or give them placebo and vaccine, new vaccine. So in this case, really, you are comparing the same individual. Therefore, the test is more sensitive and likely to produce a significant result, more likely than if you compare different individual. Therefore, we say, of course, that the paired comparison is more powerful, and has a high power to produce a significant result. Paired comparison or PERTI test or paired non-parametric test has more power to detect difference, to say that, to reject edge knot. Why? Because of less variability. The variability is important in statistical test. The less the variability, the more likely you obtain a significant result. The more the variability, the less likely to obtain a significant result. And of course, really the variability between the person and himself is less than the variability between the person and another person. Okay. So this is really something that you can really obtain later on. You see in your life, especially when you take you can make matching or match study or paired comparison. It is more powerful. It is more likely that you obtain a significant result. However, as we said, probably it is not always possible to do a paired comparison, because sometimes, for example, the drug, the first drug will affect the result of the second drug. Sometimes the time, and you need time to, for example, you need time to elapse between the first drug and second drug, and the time really may change the condition of the patient. Therefore, not always possible you use a paired comparison. Despite paired comparison, the paired design is more powerful. It's more powerful than the unpaired design, but you cannot always use the paired design. Okay. So these are really 2 important non-parametric tests. The other non-parametric test is Wilcoxon rank test, or let's return to. So this is how we have this. The really here sometimes we treat the score as paired, and here we combine them and treat them as unpaired. So really we use the same example to test use the non-parametric test for unpaired and unpaired example. Now let us close this and go to another example. Really, I want to save that really. really, I want to open another example. So really, these are. I'm going to close this really. So here we have another example really, and this example really from dentistry. So we have here really we have four groups, and we have in every group really we have 15 teeth, and these 15 teeth really are tested for experimentally. This vitro study. They are they use a technique to adhere the bracket to the teeth, and after adhering the bracket used in orthodontics تقويم. After adhering this, they test the strength of the bonding. So they have really two measurements. This is called shear bond strength, measured by a certain instrument, and this adherence resistive index. So they have two measurements made for every teeth in the four groups. Of course, the first group, I think they use old method, what's called each tech, or it's and this, I think the third and second group, they use different laser power, and I think the other also use another method for the adherence of the bracket to the teeth, and then they measure this term, okay, this variable. So we have here two variables measured on 60 teeth. So there are four groups. Every group is 15. Really, here they are worried because their sample is small. They are worried about normality. If you see that, and really here this is the output which have been put in the thesis or in the have been put in the journal really, or in the put in the journal or in the thesis. So really, because they have more than two groups, as you see, the groups really both the shear bond strength and the adherence resistive index, both of them, as you see, they are not normal, and the sample size is small for every group, only 15. Therefore, they use a test for more than two groups, just like ANOVA. The test called Kruskal-Wallis. Okay. Of course, after doing ANOVA or Kruskal-Wallis, is called something called post hoc, which examines the difference between each group and the other. And because Kruskal-Wallis, they don't have post hoc test, we use the Mann-Whitney test in order to test the difference between each group and another.
You mean, Doctor, this is alternative to the parametric test?
Yes, because the distribution of the data, as we see, if we test this, let's see, really, there's another coming from one of you, really. So if we test the output or the measures, really the output measures here, or the independent variable, the dependent variable. And this is the independent variable is the group. This is the dependent variable is the group, the group of the experiment. And these are the outcome. Okay, so we have two outcome really. If we test them really, again, if you test them by the both of them, you see that they are not normal. So if we come to, let's go. Well, really, I have to mute someone of you. Really, I have to mute someone of you. There's, I mean, really, I know it's here. Okay, now, so really, again, I will test this for normality, both of them. I see they are, as you see, both of them really, they are they are not normal, both of them not normal. Here, really, you have to worry. As Dr. Burhan said, well, you can obtain this even for large sample, but when you have a large sample, as we said, the central limit theorem help us, because central limit theorem said for large sample, the sampling distribution in the population is normal, even if the original distribution is not normal. But here we have a small sample of 15 in every group, and we test them, the normality is rejected. So really, here we have sickness to the right side, and also here we have a clear sickness to the right side. Therefore, really, the researcher really felt that he need a non-parametric test, really. Despite that, he's similar to a journal. Really, they requested to that they do parametric here, parametric finding, like the range, the mean, standard deviation, and then test by non-parametric. Really, yani, if this is not request of the student, I will simply probably I will put only the median and what's called the interquartile range. But because he have seen this in a journal, usually Indian journal, so he requested this to put all these data, range, mean, standard deviation, standard error, which are not used really in the test. And these tests, all these tests really depend on rank, not depend on these values. So really, it is not appropriate. Really, I think this is not appropriate. It is better to put the median and the interquartile range, and to put the result of the non-parametric test. But still, student really have seen this in a journal, Indian journal, and he requested this, which is really, I see it is not appropriate. So really, we have done a Kruskal-Wallis test for the three groups. As we can do it here again, we can do Kruskal-Wallis, which is really similar to ANOVA. So this is similar to ANOVA. We'll put for example, shear both strength, and grouping variable is a group. There are four groups really. There are the 1 to 4. 1 to 4, there are 4 groups. And really there's median test, and there's also this test I don't know. There's a test called median test, and also there is a Kruskal-Wallis. So I will do a Kruskal-Wallis, which is similar to ANOVA. We have taken ANOVA. We say ANOVA is parametric test for more than 2 samples. When we have more than we have 2 samples, we do t-test. However, when you have 3, 4, 5, more than that, we test the mean, the difference between their means by ANOVA, analysis of variance. And we took analysis of variance really. Now, if the distribution is not normal and the sample size in every group is small, we use non-parametric test, which is here called Kruskal-Wallis. Okay. So this is okay. And this Kruskal-Wallis again depend on the rank really. Again, rank here. So rank really, again, not useful really. Therefore, I said the student requested to show this, the mean standard deviation, the original, which is not the rank. Then the result is significant. So overall, Kruskal-Wallis is significant. Of course, if you do ANOVA, usual ANOVA, I think it will always be significant. So ANOVA is significant. Now ANOVA really have ANOVA. The parametric tests have a post hoc test, like as you said, CDAC, home CDAC, or Baffaroni, or least square LSD, or Duncan, etc. But here, really, Kruskal-Wallis really in SPSS, they don't have a post hoc test. So what we have to do, Mann-Whitney. We have to do Mann-Whitney for every group. So I go really, I do Mann-Whitney for every comparison here. Of course, some statistical package like sigma plot or I think sigma plot or midcalc, there is a post hoc test for. There is a post hoc for Kruskal-Wallis, but in SPSS they haven't put that. So we do Mann-Whitney for comparison. So I go here, I compare this group acid H with the other group. So I made a Mann-Whitney test, and that was significant, just like we have done previously with the previously with the score test. So I enter the two score, the acid, I compare the first group with the second group, and this is the Mann-Whitney result, significant. Then I compare the first group with the second group with the third group, and this is the result, not significant. Then I also compare the first group with the third group, okay? With the fourth group. So these are all Mann-Whitney tests done individually, not automatically like in ANOVA. Then really I left with the comparison. Since I compared this and this, I left with the comparison with the second group with the third group, this one, and the second group with the fourth group. Okay, it's not significant. If I finish from that, then to remain the third group with the last group. Okay, with fourth group. So I compare this, the third group with the fourth group. So I produce what's called a matrix really, and if I put here the comparison, it will be repeated. It will be repetition. So I put this comparison, and all the comparison really are shown here, and we can say these are significant. These are not significant. Okay, so this is really have been done manually. The comparison was not like ANOVA, it's automatic. The result will appear automatic in a matrix. What's called post hoc test. Really, I have done this manually, and also I draw a box plot. Really, box plot will show the median and the interquartile range. So it's better, really better than a histogram, or better than a line diagram for comparison. So these are, you see that these are the box plot for the first group, second group, and really the third group and fourth. You see the first group really is really quite different from second group, but probably third group is not that different, and therefore we obtain a non-significant result here between first and third group. Also, we obtain a non-significant result between the second and the fourth group. Okay, the second and the, okay, see they are not so different. Okay, so the histogram, this is a post plot, really give us idea about the comparison. Okay, so this is really what we call a Kruskal-Wallis test. Okay, a Kruskal-Wallis. So when I put really I haven't done this with the Kruskal-Wallis. I simply take the p-value. Really, I have done this with the custom table. I done this really with the custom table and added this column for the p-value. Okay. Really, another thing was correlation. So you want correlation between the two measurements, the SBR, the shear bond strength, and the resistive index, or the adherence resistive index. So this is really, again, because the data are not normal, we do it with the Spearman rather than person. Person is the R, usual R, but when we have skewed data, we do the Spearman. Okay, so let us go show how to do Spearman really. And again, here we go here. Well, it's done here really. So really, we enter this, both these, and we request Spearman. Okay. Okay, we request Spearman. Okay. So this is really Spearman. Okay, but this is really given for overall sample really. Really, this is given for all sample. There is association. Association is present really. There's association between the two variables. It is really given for the whole. While here is requesting that it is done for every group, for every experimental group. So how we do that? And we can do that. Really, we have to really here we for every group really we haven't obtained a significant result. Let's see how to do that. We can do that really by more than one method. We can select select every group and do the correlation, or we can do here, for example, we can go to split file and we say, well, organize output by group. Okay, we say okay, and then we request the same thing. We request the correlation, and then we say okay. So it produce really correlation for every group. This is the overall really overall, but this is for every group. This is the overall for 60 teeth. But this is for the first group really, for the acid itch. This is for the first experimental group. This was not significant as you put in the table. Then this is the second group, again, the laser, 1 watt laser, again, not significant. This is the 1.5 watt laser, again, not significant. Very small correlation. And again, this is again, very small correlation. This is the 2 watt laser, again, not significant. For all of them, I put here in a table. This table, I designed this table by myself, really, in a Word file, and then put it here. Okay, so I simply make a table and put the number of the H of the group, then put the Spearman row value, copy paste from here, from the output. Okay. So I simply copied this and copied the p-value. Okay. Okay, so this is how to do correlation. Okay, so this is really the main non-parametric test. Sometimes, of course, you may need to do what's called really there is one called one sample. Really, one sample. This is really test only the normality. Okay, but there is a test called sign test. Really, I don't know if it's right or not. A sign test called really not present here. Sign test. Really, sign test also is similar to the one sample t-test. Sign test, called sign test. I think here we can use binomial. Really. So suppose now we have a binomial really suitable for proportion, not suitable. Really, it's a proportion, then we can test proportion. If we have, for example, proportion to yes, no, or disease, not disease, died, survived, we can use the binomial test. But really, the sign test seem that not present here. Sign test call not present here. Sign test really. So so we use this two independent, similar to the Ampere test, and this is really similar to the PERT test, and this is really similar to this is classical Wallace, similar to the ANOVA. Okay. Okay. This is a related sample, really called the Friedman test, and really here we have the group should be related. Yani should be related. So suppose that we are the same group and the same individual or the same teeth, we have done the 4 experiment on them, the same teeth. this case, we use a paired. We use this one, the last one, or use the Friedman. So Friedman simply tests for Friedman similar to repeated measure ANOVA. Okay, similar to repeat measure ANOVA, Friedman. So and we need to have a pair. We need to do the experiment more than 2 times on the same individual, on the same teeth or the same bacterial colony. So if we do this, then it's called Friedman test. It is repeated measure test on the same individual or the same sample. Okay, called the Friedman. It's similar to repeated measure ANOVA. Okay. So these are really the parametric tests. Usually you need them, especially when your sample is small. When your sample especially is less than 30. Okay. Okay. Really for any. Well, this is usually he requested that we do for the score. There is score. We can of course analyze this with the non-parametric test, or really they have requested to analyze as a categorical data. We can't do again this as a categorical data. So we use Fisher exact test because really there are many values which are zeros. So we have low frequency. Therefore, we have done this with the exact Fisher test, with the categorical data, and really I think Dr. Saeed requests that I show you something how to convert the table into from Word to well, simply I said copy paste. Okay, so if I want to show, for example, this, I want to convert this into a Word file. Okay, suppose I want to convert this into Word file. Really, first there is something unnecessary here. It is repetition here. It is repeated. So I will delete this. Even I can modify it in the SPS file before I transfer to Word file. So I will remove this. Okay, I'll press this 2 times. So I will remove this. Okay. So I end by this. So I can go and well, I say copy paste. So not that difficult really. I go here and make a Word file. And I open the Word file. And this I copy paste. Probably I will allow line for the title of the table and paste. I say I will usually make this like this. So I will remove this color. Then I will make it black, the letter make it black. So I make it black. Then I will make it Times New Roman 12 or 14. Well, I have shown that in the previously. Then I will put, for the first time I'll put all the lines. Then I can put the line according to the instruction. بله.
دكتور العزيز، بس المجلات يقبلون بال 12 وال 14 لو على الاكثر 9 و10 سايز مال tables.
No, they request really 12. Most journal 12 or 14. 12 is okay. Thesis, of course, usually is 12 or 14. The thesis usually 13, 14 or 12, depend on the instruction. Really, I'm not sure. 14 or 12.
طبعا انا ما دا اناقش الموضوع مع حضرتك، بس هاي كنقطه يعني انا شفت في المره الماضيه هوايه المجالات الامباكت فاكتور العالي يعني.
بله.
تيبلات بالجايد لاينز مالتهم التيبلات يريدون 9 لو 10.
Okay, you can do it according to instruction. يعني you can do it, yes. you can do it يعني you can do it according to section. Of course here you write table يعني it depends on the section really.
ولي حضرتك شلون نسويها ب 12
well 12 is okay 12 really it's a very large table. It's a small table, even you can do it 14. If it's a large table, even you may use really 10. You may use 10. It's very large table, very extensive table. But I really bring you a small table, so you can use 12 really. 12 is okay. 12 is very suitable really. You wrote here time in Roman. So in this, for example, we say correlation or correlation between etc. I will write table, the title of the table. Then I will really remove row. Then I will probably what I will do with this. Yani it is probably I put here the 0 here, put the 0 here, and probably I will have here an O. Okay, probably I will here remove this. I will put the p-value. P-value I make it really italic. Okay, so this is the what we do here. Well, this is not useful, of course. This is useful, not useful. I will remove this. I remove this. I will delete column. So this is a correlation between a shear board strength and adherence resistance index. Really, this is not suitable. I think we put less than 0.001. Okay, because 000 has no meaning. Okay, so this is a table. Okay, probably يعني you might be requested to remove the inside of the table, as Dr. Reader say, and you may remove the inside. Probably then you put a top line and bottom line. Okay, probably you put also a title for the title also. You put. Okay, that's okay. That's nice. Okay, I don't know. Probably put also 9 here. Also a line. Probably put an upper line here. It depends on it's suitable. Okay, this is suitable for publication, I think. Okay. Okay, so this is suitable for publication. Okay, you're right of correlation between etc. So this is really for correlation. Of course, for chi-square again, and you try, of course, to make it suitable for publication.
عفوا دكتور بس
Okay.
سؤال آخر.
If it really, as Dr. Burhan said, I agree with you. If it's large table, sometimes really I make it many column, many. If the table is crowded, really, I may decrease the font to 10. Yes, 10.
صحيح.
10 probably, yes, 10, 11, okay. I make it 10 or 11, yes.
العفو دكتور بس بالنسبة للنمبر كلمة النمبر يعني the word number هاي همنا اكو فد شي بيها مثلا n بالكابيتال لو small مثلا بالجداول احنا نستخدمها لو هو نفس الشيء.
N, well, if N also okay. It depends really on the journal and on the section of the thesis يعني. Depend on the section of the university really. I usually write N or
لا قصدي يعني n capital لو n small يعني.
Well, use N small. Well, why not? يعني you can put N small.
They said I think they said that the n small is for the sample and the n capital is for the population. I think. Is there
yes,
anything
you
like
put
this?
N small. Yes, you can put N small, but يعني when you put number really, you mean number, not the sample itself يعني. But if you mean the sample itself, you can put N really. Especially in the top really, you write here يعني write N. Okay. Really, these are the regulation of the journal, and you have to read the regulation of the journal, and also you have to read the regulation of the university, and put according, because sometimes also they ask this to be bold. Sometimes they ask this title to be bold again. And well, it depends really on the journal. Sometimes they ask to put lines. Some they ask you to remove all the lines. I don't know. Yani, depend on really on the journal and on the. Really, when I publish something in the journal, I look to the journal. I go to download a paper from the journal and make the table as they want, okay? Okay. So I don't know whether Okay, so agree next week, inshallah, on Dr. Saeed, try to go to the model and see the first presentation in the model, so that you see how we convert the file into Word. Okay. Again, of course, the Word file depends on the regulation, depend on the journal. Okay. Okay. Now, really, I agree so that the next week will be an exam, and I will send you the file. Then we'll meet in the college, and you bring your laptop, and I will give you instruction. It will be simple. Really, it will be a simple table, just a trial to exam. Really, I haven't done that previously. I haven't done really. I haven't presented or made advanced statistics or analytic statistics course. Okay, this is the first time really. Of course, it will be simple really. The exam, I'll try to make it, the instructions clear, and it will be easy. Okay, inshallah. Okay. Okay. Now, can I stop share? I don't know if you have questions. I think our time has finished. Okay. Okay. Okay, Zdrissa.
Thanks a lot.
تمام دكتور.
Okay. إن شاء الله. بخاطر هو موفق بين إن شاء الله. موفق بالهمين.
قالك ممنون دكتور. قالك ممنون بزحمة وتتا ممنون.
خير بتشين بخاطر هوا.
We appreciate.